Hello everyone, back again. This is Manna Mahmud, and today we are going to discuss on enterprise cloud management and the distributed systems, how RDBMS is lagging on this and how Kubernetes is helping on this. So, this is the basic topics we are going to discuss. Now, this distributed thing, distribution basically very old thing. Before the cloud concept, it was very much available there, and we used to do like without any app server, even in Geo 1, Geo 2. So, you have one server here, you have one DB here, and the DBMS used to give the features. They call it like they can have multiple clients on it and the DB connections. Client 1, then you can have a client 2. This one also have C1, client 1, client 2, and to have a seamless data experience, you can have this thing we used to call replication. And this replication is the key feature to have your distributed system, the data experience seamless. And now this RDBMS we used to expect earlier. They used to come up with very unique techniques and ideas of replications. In Oracle 9 I came up with advanced replication ideas, partial schema replication ideas. They come up with streaming ideas. We have found the DBMS has come up with this sort of unique ideas. So they used to provide the facility to create good distributed systems. So and then advancement with the web technology, ASP.NET, J2EE improvement, and so many things. We got this application server layer, and then came DB. But still now, if you want to make this geographically distributed thing, then you have to have these instances of this application server, then this web server, then maybe a web app on other things, but you have to have these instances closely available to Geo 1 and Geo 2. Fetching data from Geo 2 to Geo 1, maybe Geo 1 is in London and Geo 2 is maybe in India somewhere. So fetching data, it sounds not logical. So you have to have instances of the application here and here also, and having these instances in different places along with giving the data seamlessness, you have to do the same thing again. There is no alternative. You have to do this replication. There was scheduling, there was job things, do these replications thing, and the DBMS, still DBMS is ruling, and they are highly priority. They are getting the market, and they are doing good. But here you see, when you have multiple instances and the technology involved, now you are saying you have a DB, and now you have added something called app server, and here you are adding multiple tools, messaging server, search engine. Now you have here different sort of load balancers. Then you have like what it is called, introduced newly, ORM, data session. You are introducing so many tools in this layer. So you are giving this, what it called, so many frameworks here and tools, and the DB here and then above that you are coming with apps and the tools. So many resources for single instance, and these resources maintaining becomes cumbersome, very difficult when you have regular updates, you have new features, you have new policies to enroll, and you have to deploy, and you have to deploy in your all sites, in all instances simultaneously basically. Then it becomes really hard for the team and they cannot do it, and these operations become very hard. And to make it more smoother and more things, there are two aspects of like one we can call resource proper utilization basically, or how your resource can be easily upgraded. Like you need a new feature, you need a hard CPU more or storage more, how you can downgrade, how you can upgrade. Then you need operation smoothness, that you can do it, you can release upgrade easily, and you can update a feature easily in simultaneous in all places. So these two things is very important, and first one is basically is the thing that we are business people got the scope and they made it. They are giving this cloud thing. They were previously called hosting providers, still they are hosting providers. They are basically nothing else, giving you the resources. Amazon is doing really good business providing you resources, and currently added with that some managed services that you can consume and make your life easy. But this cloud thing is basically they are giving you plug and play sort of features, and you can easily pay only what you use, and you can anytime increase your IO consumption required hardwares, and you can easily downgrade them. You can have internet bandwidth as much as you want, and you can have your things available worldwide anywhere you want. They got zones and data centers everywhere, backup, security, everything they are providing now. So you are getting less tenseless, because before that when you are doing these things on your own, all the instances in your all geographical locations, you needed a very big IT team. You need so many resources and so many peoples. Maybe if you look in some very big companies, maybe the DB team is so big, so many migrations, maybe each week they have scheduled, it will just, head will get round. This is too much things we had to do separately of our own, manage the things. But when cloud came with all these burdens and saying that okay, you don't have to do these things, we are taking care of that, then you can do your resources. But when you purchase the resource in cloud, you have all these things you had to do before. Here still you have to do, like what? You have to do your load balancing, ensuring the traffic consumption of your resources that is mostly needed, you can serve it without any interruptions. You had to ensure your failovers of your DB or of your application servers. You had to make the replications, redundancies of your things. So if one falls, one node falls, you can just make the other node available. DBs, you had to cluster them, master slave. So these things you have to do your own, because your need is not clear to the cloud. They are providing you services, but you have to integrate them and provide them in your manage your. So you need people over here, you need things to do in cloud. So mostly the things you need with your resources, like load balancing, then you have failover, then you have this redundant, you need this replication. These are resources. As these are hardwares, ultimately end of the day it has lifespan, it has outage problem, it will run out of its capacity, it has so many maintenance issues that you have to manage with these resources in the cloud. So that is something become headache. And then the thing came like provisioning, like you have to do these things and environments. Now for three sort of people you have in your organization, these things like those are the operations. You have the resources now, but the resources, how much resources need for home need, this operation, there are so many sort of operations and the user ends, like you have to satisfy your users. They can be employee, they can be your customer. Then you have your dev team, then you have your quality control team. They have so many operations running on to satisfy the users, deliver, give the regular updates. So related to these operations, these users also get to use the resources and in the cloud. So how to manage those things? This term the company came up with DevOps. So altogether, this infrastructure and the operations managing, they came up with the idea of DevOps, and the idea of containerizing container is a bundle that is basically a mini VM, you can think like that, which is basically giving you the scope to specify how much resources, IO consumption, CPU, memory, storage you need for a specific application. You can bundle it and you can just make image and you can just ship it to any server you want. So this container concept and the DevOps together, it is like a revelation, made it so look good and smarter way to manage the operation faster, do the releases faster, team faster. So having this bundling of feature and this DevOps theory of conceptions and people, now the market introduced a product to managing these network resources, and they are calling this Kubernetes. Now the thing I want to tell you, like these applications when we are running without cloud in our on-site premises, we are running these solutions, instances, hardwares. We have to do all the operations of our own. Still we have to do in cloud, but the resources we are getting from cloud. We have to resources tagging, asset tagging sort of thing, like these are application servers, these are DBs, these are search engines. Okay, this sort of things we have to classify, we group things, we name things. Other way of naming things application wise. So there is a ERP team, like call it, these are DB team, these are HR application team, they are portal team, so they are web team. So this way we say team, and of course the hardware, servers, deployment, resources separate, different from them. Though end of the day they need an integration with each other, but they have separate way of developing things. So this way we cluster, we group things, grouping things. This is the concept of managing resources, and we call it basically clustering. Clustering things. You can have resources clustered app wise, ERP. So all the resources related to ERP. You can have clustering environment wise. What is environment wise? Like we call dev, we call test, we call prod. So these are environments. So environment wise you can have clusters. So dev related, whatever applications are happening, dev related hardwares, nodes are, yeah, this is a group, this is a cluster, test is a cluster, prod is a cluster. There is more other ways, like only one cluster and then you just tag your own way. So this is only one cluster, whole big one cluster. And then there is another clustering, that is basically we call multi-clustering, and that is very important. You can't, as we are discussing this distributed system, you need multi-clustering end of the day. If you are really big and you have geographically 1 and 2 position, and you need the resources to be distributed in cloud, clustered separately, the multi-clusters you have to manage. But yeah, we will discuss. So then Kubernetes basically added some feature which they call federated clustering for this multi-cluster management. So so you can have a management, but there are some complexities of deployments in multi-cluster. Same thing, we will discuss it later, but yeah. So the basic thing is managing these clusters, group of resources from single place. You need Kubernetes. What you need to do this clustering management? You need a dashboard. So Kubernetes gives a dashboard. So Kubernetes providing this dashboard through Kubernetes architecture, they are calling it master or their server. So Kubernetes gives a server, and it has to be deployed in a node, that is server node, and it got basically DNS, it got a API gateway in it, API service they got, and it got controller. Okay, so it has all things in it, and yes, there are some other services in it. So this master, and then you server, and then you have clients like workers, they call it workers. You can have multiple workers, multiple worker nodes, and when you have multiple worker nodes, so you deploy in a node is a master Kubernetes, and then you deploy worker nodes and as many nodes as you need, and then they can have a communication way, and this can give you the dashboard. You can have a control over all your all nodes and resources, everything is in your cluster. So when you have this master and the server, basically the worker in then you can deploy, they are calling it, and this under the worker you can have this pod network. So what is this pod network? Pod network is a wrapper on the containers. So one pod can have multiple containers. So this is the way to this Kubernetes application. It's of course an application, it's having a control on its clients, on its things. So they used a wrapper pod that is on the containers. Through that it provides the services that we need, like a bit ago, load balancer, failover, and any control over that, and tracking, monitoring, all these things, basically tracking, monitoring, all these things, this is the thing it will provide you, the pod top of the container. So what we are finding? So we have master, then we have workers, then we have pod, then we have containers. So this is the way to compose a terminology of a cluster with the Kubernetes. So this is pretty simple. We are planning to do it with Amazon, AWS free tier, and we will do that. So so on, but today we are discussing on some theory, so we can do it clearly. So on that thing, like as we are talking, that there is interesting thing, the cluster, making the cluster more dynamic. Kubernetes introduced a virtual clustering. In the physical cluster you are creating with the Kubernetes master, you can have virtual, multiple virtual. So there you can call it namespace. They call it namespace. So you can have namespace. This is basically a virtual cluster. So isolation of resources. You can give a name. You can tag resources and isolate them, the operations with the namespace. There is an example I can give, like you can say in a master and give a name is like your application maybe ERP. So you can say ERP dev, a tag, ERP test, and then ERP prod. So what's happening here? Same in a single Kubernetes cluster, you can have these 3 namespaces. Under these 3 namespaces, you can have multiple pods, basically containers, and you can have each one is containing an instance of ERP with all application servers, DB, search engines, whatever you need, and then similar in the text. And but all the deployments will be different. So after you've done something in development, you can push it to test, then you can push it to production, and their whole thing is totally be different. The resources management will be different, and you can assign resources as you want, the user access as you want. So this is a way to avoid, if you want to avoid multi-clustering, you can do this with namespace in a single cluster, but you can give a multi-cluster field. And but again, what it happens if you do this, as this master server is basically shared resources, this control plane, it gets a load, high load, and then because all these namespaces, all these resources that you will increase, they all will going to be managed by this master one. So sorry. So yeah, but when you have really do some multi clustering, you need to do multi clustering, then the basic trouble happens with, as I told you, can do it easily. You can do have geo, you can have geo 1, geo 2, and you can do Kubernetes cluster 1, and you can have Kubernetes cluster 2 of same thing, like for ERP. So for ERP you have for geo 1 cluster 1, but this is the same application, same ERP, so you have feature updates. The same issue comes again with less hardware management, but updates and the releases, upgrades, and making things, and again the replication, because here is also persistence layer. We just going to discuss about the persistence layer with the pod, what is the issue, but yeah, this is also comes the issue of replication. So you have to have good replication way of your storage and your deployment. So deployment, we can call it basically shipping, right? Shipping, cargo. So the shipping containers simultaneously on your updates, on your releases, on both the clusters, that's a challenge. So Kubernetes federated, I think there is a version, and they provides that, but end of the day, I think you have to have your own shipping and deploying mechanisms over that to have a proper one. So this is an option, but for doing distributed multi-clustering things and very hectic thing for DevOps, you have to concentrate on this. Number 2 is basically today we are going to do in this layer, when you are trying to do some distributed thing like big companies like Netflix, like Booking.com, the like big company who are having worldwide so many servers, so many distributed instances to run, this DB is getting an issue for latency for replication. So here we have to understand two things. One is we are calling stateful thing, one is stateless, right? So pod is very good. Pod is not that heavy, consistent like a VM, but pod is a container thing that is less stable. It is basically, it can go down, another pod will come up. So it's like that. So there is nothing memory persistent thing like state. It is not containing state. You can restart it, the pod, and it will just restart again with the all features configuration. So the configurations written there is very good with the configuration management. It will just, you just start it, it will just start new node, and one down it will just pop up in another thing. So these things like all these application servers, search engines, message brokers, all these log servers, everything is mostly, you will see these are the applications that are running microservices. These are stateless basically. But specifically the RDBMS, it is the application that is basically doing the state thing, the storing, persisting things, it is keeping the state. So for these things, pod are not that good. They are working on it. So they came up with alternatives, going pod, working on that. So what is their cloning? There is a cloud friendly DB. So friendly, they are calling native. So native and friendly, someone thinks native, what cloud native? Cloud friendly apps, this cloud friendly DB. So cloud native, cloud friendly DB. Why this is, you are saying, there's the word replication again comes. So these are very good with replications. MongoDB, NoSQL, not that complexity or like the monolithical RDBMS, so many ways of configurations and other things to replicate. There are so many things to do. Simple, very straightforward. Operations are automated with Kubernetes. You can easily do this replication automation, and as much node you can easily downgrade, you can upgrade, you can increase, you can decrease things easily. So this is the cloud nativeness. So in Kubernetes, if you want to run the RDBMS monolithical things like MySQL, Postgres, they are trying to automate their things, they are trying to make this cloud native. But yes, before that, so many organizations come up with nice things, cloud friendly. Those are easily, you can down and you can up, and they will not lose data, and they can easily replicate it. One of them is very much popular now, that is called Apache Cassandra. We are going to work with this Obis and Apache Cassandra. So this is basically cloud friendly, cloud native DB, who is very good with these replications things in distributed geographically wherever you want. Netflix is using Apache Cassandra. MongoDB is something also like that, and these are called NoSQL. So it's basically meaning that you can do the queries, you can do all these things. You need this friendly structure of data querying, but the thing is, it's not that RDBMS thing. But it's of course maintaining the ACID, all the consistency properties for the transaction logging, transaction log, everything they are maintaining, they are doing that. But it's that lightweight thing, and to do the nodes increase and downgrade and these things. So this is the thing basically we are trying to discuss today most and yes. And so RDBMS currently we are to cope up with the Kubernetes is not going on. distributed. We still very good with distribution now with cloud, but we have to think RDBMS in a different way now. We are doing these things with now currently good with these NoSQL things, and we have a very switch knife now a bit like Kubernetes, who is giving you all packed with the pod network, load balancers, failovers, all the maintenance headache, monitoring, a dashboard to see what is not using that much IO, which is highly using, which need to be upgraded, and a very excellent way of clustering and giving you this DevOps of dev, test and prod automation. That is the biggest thing. DevOps very liking these Kubernetes things, this Docker and container shipping to these environments according to the releases. So yeah, I think I should not increase that anymore today. So in future we will try with Kubernetes in AWS, and that will be like AWS, then Obis, then Cassandra with this cube thing. We'll give it a try. So it's going to be more technical then. Till then, have a nice time. Thank you.